Okay, friends, so this video is going to be on determining if a function is even, odd, or neither. A function is even if it is symmetric on the y-axis. So if it is symmetric to the y-axis, in other words, if you fold it along the y-axis, if it will land on itself. It is odd if it is symmetric to the origin. Okay? And then, of course, I have all the notes that explain all of that over here. But if we look at this first graph, and we were to fold it along this line, if we were to fold it on the y-axis, then we would find that this curve would land right on top of this curve. So this is even. Another way to think of that is if you took the right-hand half of this graph, if you took it and you flipped it over, would it be in the exact same place on this side? And the answer to that is yes, it would. So this piece right here is this right-hand side flipped over. And when we flipped it over, it landed right on top of itself. So that makes it even. Okay, this one, if we fold it on this line, it will not land on top of itself. If we were to fold it, if we were to take this, copy it, set it right there. So there it is. And now if I take it and I flip it, it will not land on top of the graph that was already there. It didn't land on top of itself. So it is not an even function. It is also not an odd function. And it's not an odd function because if you fold it across the y-axis and then fold it across the x-axis, it won't land on itself either. Or the other way to think of that is if you took this picture right here and you turned it 180 degrees, do you get what you started with? And the answer is no, you do not. So turning it 180 degrees didn't put it back the way it was to start with. So this is neither. So this one we are going to say it is neither even nor odd. Okay, this one. If you fold it along the y-axis, it lands on itself. So this is going to be even. In other words, if I took the right-hand side, there is the right-hand side. If I took the right-hand side, and I folded it across the y-axis, then it would land on top of itself. So there it is, landing on top of itself. So it is an even function. Okay? This one, if I take this function and I take this function right here and I turn it 180 degrees. It lands on top of itself. So this is an odd function. Okay. The other thing I would like you to notice is if it is an even function, let's go back here. If it is an even function, then if I have a point 1, 0, I also have the point -1, 0. If I have a point, let's say that's the point 3, 3, then I'm going to have a point -3, 3. So when this x is -1 and this x is +1, the values of y are the same. If this x is -3 and this x is +3, in other words, the same, the x's are opposites of each other, the y's are the same number. That's a definition of being an even function. So that's not true. So notice here that I have a point right here. That would be the point 4, 1. So if I have the point -4, 1, it would be right here. So that doesn't work. Right here I have a point -1, 2. That means I should have a point 1, 2. And I don't, so it doesn't work. Okay? On this one, if I look at this, right here is the point. Oh, hang on, sorry. Let me delete that. There we go. All right. This point is the point 1, 0. This is the point -1, 0. In other words, the x's are opposites of each other, but the y's are the same. So this point right here, this looks like the point -2, -4. So I should have over here the point 2, -4. In other words, the x's are opposites of each other, but the y's are the same. This point right here, this point looks like it could be the point -3, -7. That would make this the point 3, -7. Again, the x's are opposites of each other, but the y's are the same. That makes it even. For odd, what makes it odd is if you have an xy, you should have a -x, -y. So in other words, this point right here, let's say this is the point 2, 1, then I should have the point -2, -1. -2, -1. Notice the x values are opposites of each other and the y values are opposites of each other. If I have this point up here, this looks like this could be the point 3, 4. That means I should have the point -3, -4. In other words, the x's are opposites of each other and the y's are opposites of each other. That's a definition of odd. Okay? So then let's look at this. All right. If I'm going to check for even. I'm first going to write the problem y equals 1/4 x to the third power. And I'm going to highlight that because that's what I'm going to be looking for. Okay. Then I'm going to say, I'm going to let x equal -x. If I do that, then I have y is equal to 1/4 And instead of writing x, I'm going to write negative x to the third power. Then if I simplify that, simplify, I left the L out of simplify. If I simplify that, I'm going to have y equals negative 3 times negative, I'm sorry, negative x times negative x times negative x is negative x to the third power. So that would be 1/4 negative x to the power 3, which would be y equals negative 1/4 x to the third power. Okay? Notice that this and this are not the same. So, not even. Okay, so that was the check for even. Now we're going to do the check for odd. Okay, so now we're going to do the check for odd. If I'm going to do the check for odd, first of all, I'm going to write y equals 1/4 x to the third. And what I'm looking for is to get this back again, okay? Now I'm going to say, let x equal negative x and y equal negative y. So if I go to do that, y is going to be negative y, and x is going to be negative x. Okay? Then I'm going to simplify it. And when I simplify, I get negative y is equal to negative 1/4 of x to the third power. Then if I divide both sides by negative 1, I get y is equal to 1/4 of x to the third power. And then this equation right here and this equation right here are the same. So it is odd. So it passes for odd, so it is odd. So that is the check for odd. The check for odd is to replace x and y with their negatives. Okay? All right. The other thing is to look at it, y equals 1/4 x cubed. So if we go to Desmos, and we go y equals 1/4 x to the third power, and look at it, okay, this right here is the ordered pair 2, 2. This right here is the ordered pair negative 2, negative 2. This right here is the ordered pair 1. So I should have a negative 1, negative 0.25. So right here is a negative 1. There it was for half a second. I had it. Negative 1, negative 0.25. If I look at 2.5, there's 2.5, 3.9. I should get negative 2.5, negative 3.9. Okay? So this is definitely odd. If you don't want to look at it in Desmos because you don't have Desmos on the JCCC test, if you go into your regular calculator and you type in y equals 1/4 x to the power of 3, and you look at it, it looks like the right-hand, if you turn it 180 degrees, the right-hand quadrant would land on top of the third quadrant. If you look at your table, notice you have a 1 and 1/4. So here you have a -1 and a -1/4. This is -2, -2. Down here you have 2, 2. Down here you have 3, 27/4. Up here you should have -3, -27/4. Up here you have -4, -16. Down here you have +4, +16. That means that that is an odd function. When every xy is a -x, -y, that is an odd function. So if we go back to here and we look at this, okay, if we do a test, if we test for even, if we do a test for even, well, first of all, we're going to make it, yep, let's just do it. So we're going to let x equal -x, all right? So that would be -x to the power of 2 is equal to 2 times -x, y minus 1. Oh, I need to leave, dang it. It's going to leave you x squared minus 2xy minus 1. And you'll notice, please, that this equation and this equation are different. So it is not even. Okay. Alrighty, now let's test for odd. So if we run a test for odd, we're going to let x equal -x and y equal -y, which means we're going to have parentheses, -x, close it, square it, equals 2 times -x times -y minus 1. That gets us x squared equals 2xy minus 1. Notice, please, that this equation right here and this equation right here are the same. So it is indeed odd. If we would have done it algebraically, we would say that let's do it algebraically. Let's do it algebraically in blue. We would say 2xy is equal to -x squared. Hang on. Let me change that. I'm going to solve for y, which means I have 2xy equals x squared plus 1. I would divide by y, which would give me y equals x squared plus 1 divided by 2x. X squared plus 1 divided by 2x. X squared plus 1 divided by 2x. X squared, I forgot what it was. X squared plus 1 divided by 2x. X squared plus 1 divided by 2x. If I look at the table, it looks like that. In the top right hand corner, if I turned it 180 degrees, it would land in the bottom left hand corner. If I look at my axes, notice here I have -1, -1, my ordered pairs, and here I have 1, 1. Here I have 2 +5 4s. Here I have -2 -5 4s. Here I have -3 -5 thirds. Here I have +3 +5 thirds. So for sure it is an odd function. Okay, and the last one. Let's test for even. If I test for even, we are going to First of all, rewrite the problem so it says y equals x squared plus 1. Then we're going to let x equal negative x, which means the problem would be y equals negative x squared plus 1. If we simplify that, that would be x squared plus 1. We will notice that this equation and this equation are the same. Therefore, it is even. If we would have put it in our calculator, and we would have put x squared plus 1 and graphed it, if you fold it on the y-axis, it lands on itself. If you look at the table, here where you have negative 1, you have a positive 2. And here where you have positive 1, you also have a positive 2. Here where you have positive 2, you get a positive 5. Here when you have the opposite of 2, you still get a positive 5. Here when you have the opposite of 3, you get 10. And here when you have 3, you still get 10. Here when you have 4, you get 17. So when I get to negative 4, I should still get 17. Here when I have a negative 5, I get a 26. At the bottom where I have a positive 5, I get a 26. That's going to make this an even fraction. All right, my friends. That is it. Have a great day.